This is number 11 on the 2021 March instance of the SAT exam. I would categorize this one as difficult. Let's see what it says. The graph in the xy plane of the equation above contains the point A, comma B. If A is between -1 and 1 inclusive, which of the following is not a possible value of B? Okay. So what in the world is this asking? And this is not a typical looking problem at all. So that's part of why this makes it difficult. It's not a very common type of problem, at least from the tests that I've seen. So students that just follow procedures and know algorithms and follow them to T won't work well when they're given a new situation like this. Okay, that's number one of why this problem is probably more difficult. And just the concept itself is not that difficult, but it's more on the intermediate end. So a combination of both of those will make this problem hard, in my opinion, for most students. But let's understand what this is actually trying to test, what concepts this is trying to test. This is asking about polynomial behavior. So if you've taken an algebra class like algebra 2, or maybe you're in the integrated math stage, so I think math 3, math 2 or 3, you studied polynomials, most likely. And you learn how to find zeros of polynomials, and you find out you have to like find when the polynomial increases, when the polynomial decreases. And then more advanced topics are like, when is it concave up and down, and what's the end behavior? But this particular problem is asking about when the polynomial increases, what intervals, and what intervals it decreases. Remember all that stuff that you might have had done in the polynomials chapter? This is what it's actually testing. So let's solve it with that in mind now. So this is asking what is not a possible value of B. A is between -1 and 1. Okay. So notice where the zeros of this polynomial are. So we set y equal to 0. So 0 equals this thing. So we can use the zero product property. By the way, zeros of a function are when the y value is 0. Hopefully we remember that. So that's why we set y equals 0. So we use the zero product property. So x can be 1, -1, or -2. That's what the zeros of this function are. Okay. This is helpful because this is asking for a between -1 and 1. A is the x coordinate. And we know that at -1 and at 1, the y value, which is b in this case, will be 0. So we can definitely cross c out right away. Okay, that's one concept we need to remember. And then next, we have to remember polynomials are continuous in its domain. And in this case, it's all real numbers. There's no restriction on x. X can be anything. Okay. This helps us because when we're trying to find out what happens between -1 and 1, we're trying to find out what happens between two zeros of the function. Okay. So that's what I drew the circle here, but I'm not trying to illustrate a circle. I'm trying to illustrate this point. So we have a 0. Look, 0 at x is -1. -1's right here. And we have a 0 at x is equal to 1. It's continuous. So the simplest way to think about it is if you draw a curve or a line from -1 to 1, you cannot lift your pen or pencil. You got to keep it on the paper. So to connect this 0 to that 0, what can happen? It can be a straight line. But in this particular case, it cannot be a straight line because we have a third degree polynomial. If you expand everything out, the biggest power of x is x cubed. So we know a cubic is not a straight flat line. It has to be y equals a constant in order for that to happen. So in this case, we could rule that possibility out. But otherwise, to go from here to here, you can increase and then decrease, or you can decrease and then increase. Okay? That's how you just connect these 2 points. All right. So that's what I'm saying in this third bullet point with these 2 sub-bullet points. You can connect it like this or like this over here, okay? So precisely because it's continuous, we can plug in some value in between -1 and 1, like x equals 0. So when we plug in x equals 0, what do we get? We get -1 times 1 times 2, which is -2. So at 0, it's -2. So this is -1, but pretend this is -2, okay? So in order to connect from here, this 0 to this 0, we have to go through this negative value. So that means it has to decrease from 0 and remain negative all the way until we get back to the 0. All right? Therefore, we know that these two could be possibilities and that a positive value can never happen. Once again, because we start from 0, we know it goes negative because we try to test value in between. And it's continuous. That's the key. We try to test value in between as negative. So it has to go through there and then back to 0 eventually. So it's always negative. And that's why it can never be D. And that's the answer we circle because it's not a possible value. Okay, hopefully this was helpful to understand and review these concepts about polynomials.